Sehan Air Soy are the property of the client GDF Suez and subject to copyright limitations. We thank GDF Suez for giving permission to use these animations in our channel. Whenever there is a water source at high elevation, flowing to the low elevation, it is prime candidate for hydropower generation, provided that the amount of water justifies the expense. For this reason, dams always build on the rivers in appropriate places to minimize the cost of their construction. When the water allowed to flow to the low elevation, by passing through a water turbine, this potential energy is converted to electricity. In dams the water always flows in one direction, from high to low, however in the pumped storage systems it flows in both directions. During the night the water is pumped to high elevation, and the daytime it is allowed to flow, by passing through the turbine, to the low elevation. As you can see in this animation representing the night operation, the water is being pumped to the high elevation lake by a Francis turbine. The electricity is pulled from the grid to power the Francis turbine, which is working as a pump. Notice that the water level in the reservoir is rising. Note also that the Francis turbine is located below the river surface level. This makes pumping operation possible. The water is pumped uphill to generate electricity from it later. This seems strange, because everyone knows that, pumping the water to the high elevation requires more energy, than the energy generated by the same water flowing in reverse direction. The catch is the price difference in the cost of the electricity. The price is much lower at night than the daytime. This is because, the daytime electric consumption far exceeds the night consumption. Here is the animation of the daytime operation. Note that the power plant operates just like a dam. The water flows downhill, and the generated electricity is fed to the grid. The water level in upper reservoir is falling. One might ask why not the power plants, whether it is a dam, coal, nuclear, tidal or wind-based, produce less power at night, rather than lowering the prices. This is because, we can't control the nature. The wind blows much powerful at night, tidal power generation time is based on the moon cycles, dams allow excess water pass through the turbines day and night. And it is not feasible, to shut down a coal power plant at night. Producing excess power due to natural factors at night, generate the huge price difference for the electricity between the night and day. Pumped storage stations harness this price differences to generate the revenue to justify their existence and construction. By acting as giant energy storage systems, these vital stations regulate the power production and its price. It also regulates the climate of its